Alright class, in today's math class we're going to be learning about the Pythagorean Theorem. And it's a big name, but don't let that scare you. It's just a title for what we're going to learn. And it's actually called the Pythagorean Theorem because an old Greek philosopher named Pythagoras found this out. He's a Greek philosopher slash mathematician, and he was the one that discovered that this works. So that's why that's that. And I have a handout, and that way you guys can be paying attention to what I'm saying instead of writing down the notes while I'm talking about this stuff. I want you guys to listen to me, please, and follow along. So, the Pythagorean Theorem, this is the equation that goes with it. It's a squared plus b squared equals c squared. A and b are the legs of the triangle, and the legs are the two segments that form the 90-degree angle here with this symbol. The hypotenuse is C, and that is the segment that's opposite the right angle of a right triangle. And what can you guys tell me about these triangles up here that I've drawn that they all have in common? What can you tell me? Yeah?
They all have a right angle.
That's right. They all have right angles. See, that's what this symbol shows. Right angles. So they all have 90-degree angles. And that is because the Pythagorean theorem only works in right triangles. So if you see a right triangle, you know that the two legs squared equal the hypotenuse squared. It only works in right triangles. And some of you might be thinking, why do we have to learn this? When are we ever going to need to use this stuff? Well, it's actually a very common thing. Like in our house that we just had an addition added onto, the guy that was putting up walls, he had one wall here and one wall here, and he measured those walls, and he wanted to make sure that that angle right there was square. So he measured those walls, and then he measured across, and if the equation worked out, then those walls were square. They had a 90-degree angle. So it's common things that you'll have to use in several different work fields. Does this make sense to everyone so far? Is everyone following along? No problems yet? Okay, good. Alright, let's do an example then. Here's our first example. It gives us the two legs that form the right angle, and we're trying to find the hypotenuse, x. So, does someone know how we would set this up? Can someone plug these numbers into that equation and set this example up? Yeah, go ahead.
3 plus 4 equals 3 squared plus 4 squared equals
there you
x
go.
Squared.
You can't forget the squares. Good job. 3 squared plus 4 squared equals x squared. Our two legs squared added together equal our hypotenuse squared. So 3 squared. These are things that we've learned in the past. 3 squared is 3 times itself.
9.
9. Good job. 4 squared. 4 times 4 is
16.
16. Good job. And that equals x squared still. We haven't done anything to this x squared. We just want to drop it down for now and leave it there. Now, this is simple math. You guys can do this. 9 plus 16 is?
25.
25. Good job. We still haven't done anything to the x squared. Okay. Now we have x squared equals 25. We just want to find x. So, in order to do that, we're going to square root both sides. Because of what we've learned in the past, we know that the square root is the opposite of squaring. So that's going to cross both these off, and we're left with x, which is what we want. The square root of 25, this is another thing we've learned in the past, is what number times itself will give us 25. Does anyone know?
5.
5. Good job. So x is equal to 5. We just found our third side length. We're done with that one. That is all that the Pythagorean theorem is right now. There's our 3 side lengths. We're good to go. Does everyone understand that so far? Is everyone following me? Does that make sense? Good. Alright. Well, let's move on to our second example. And you might, on this first example, you might want to copy this one down, maybe after I'm done lecturing, and you can use that as an example for future problems. Okay, our second example. Again, it gives us the two legs, so we're going to set it up just like we did the other one. Our two legs added together squared equals the hypotenuse squared. And 6 squared, 6 times 6 is?
36.
Good job. 36. 8 times 8 is?
64.
64. Good job. And if you have problems on these, don't be afraid to use a calculator. Calculators are our friends if we need to use them, so go ahead. Don't worry about it. So 64 equals x squared. Okay. 36 plus 64 is, does anyone know?
100.
Good job. 100. 100 equals x squared. Again, we have x squared. We just want x, so we square root, square root, square root of 100. What times itself equals 100?
10.
10. Good job. So 10 equals x. So we just found our third side length again, the hypotenuse. That's the answer. So that's all it is. Does everyone follow it so far still? Good. All right, our third example. Now this one's a little bit different. If you notice, it gives us one leg and the hypotenuse. On previous ones, it gave us the two legs. This is not a problem. This is things that we've learned in the past in algebra. We plug our numbers into our equation. A squared, x squared, plus b squared, 12 squared, equals the hypotenuse, 13 squared. Okay, x squared, we don't know what x is, so we can't mathematically square it yet, so we just leave it as x squared. 12 times itself is?
144.
Good job, 144. 13 times itself, does anyone know this one? This one's going to be 169. 13 times itself is 169. Okay, we know from what we've learned in the past in algebra that we are looking for x. That means we need to get it by itself on one side of the equal sign. So we need to get rid of this 144. So we're going to do the opposite operation. They'll cross out. Minus 144 on the other side. This is stuff we've learned. So now we have x squared equals, and 169 minus 144, any ideas? It's going to be 25. So x squared equals 25. Okay, get rid of the square again. We're going to square root it. Square root it. X is equal to square root of 25 again?
5.
Good, 5. So x is equal to 5. We found our third side length again, even though it was a leg. Does everyone follow that? Would you like to do one more? Okay. Alright, let's go ahead and do one more. We'll plug in some different numbers here for another example, and then I'll give you your assignment. Okay, let's do, which one did you have problems with the most? Would you like to do one of each? Okay, yeah, let's do one of each. Let's do one more of each. Okay, so this side length will be 15. This one will be 8. This one's like our first two examples where it gives us the two legs first. Okay, let me erase this, get some more space. Okay, 15. Tell me how to set it up. You tell me. It gives us the two legs. What do I need to write?
15 squared plus 8 squared equals x squared.
Good. Good job. 15 squared, that's a little bit bigger one. It's going to be 225. Sorry, my writing's getting a little bit sloppy. It's going to be 225. And 8 squared is?
64.
64 equals x squared. 225 plus 64. Any ideas?
289.
Good job. 289. Okay, so 289 equals x squared. And these are getting to be bigger numbers. Don't let that scare you either. It's still the same process. So we need to square root just like we always have. And the square root of 289 is 17. 17 equals x. There it is. There's our third side length. 15 and 8 are the legs. 17 is the hypotenuse. Follow that? Alright, good. I think you guys are getting it down enough that we don't need to do another example. Would you like to do another example, or would you like to get started on your assignment? Assignment? Okay. Alright, we'll go ahead and assign. Your assignment is on page 50, numbers 1 through 14 all. Alright, that'll be due tomorrow. Good luck. If you have any questions, come ask me. Don't be scared, and go ahead and get started.